Okay, so now that we know the rules of transformations of random variables, let's prove them. Okay, in order to prove the expected value of a plus bx, I'm going to actually calculate it. And for this one, I'm going to assume that this one is a discrete random variable. I'm going to assume it is a discrete random variable. Okay, and so what my probability distribution looks like, it looks like, well, little x, my random variable will equal x, and I'm going to have 1, 2, 3, onwards for ever, really. So I'll just say there's 5 of them. I don't know. And so then the probability of x being x, well, this will be P1, P2, P3, and so on. And actually, as opposed to 5, let's just make it n. All right, so this is Pn. And so those are the probabilities associated with it. So if I come along, though, and I change my random variable to a plus bx, well, that's going to change this value to a plus b. And this is going to be a plus b times 2. And this is a plus b times 3. And this is a plus b times n. And so I want the expected value of all these multiplied by the probability. And so to find the expected value, let's remember our formula for expected value for a discrete random variable. Discrete variable is this. I take my value and I multiply it by the probability. My value times probability, and so on. So let's actually do that. We're going to calculate the sum. Let's find the sum. So I'm going to take the expected value of x is equal of a plus bx is equal to the sum of a plus bx sub I times p sub I, or px sub I, which I know that that's going to be the sum of a times px sub I plus bx sub I times the probability of x sub I. Well, here I can pull out a, and I have this of px sub I, and I can also do these additions separately, and I'm going to plus this addition, and I can also pull out the b here of x sub I, px sub I. Now, if we think a little bit, this is the sum of all of the probabilities. That's what this is saying. This is saying add all the probabilities up for this variable, and the sum of all probabilities is equal to 1 plus b times, well, this here is the expected value of x. That's what the formula is. It's the expected value of x. So this is b times the expected value of x. And so I get a plus b expected value of x. And so I've just proved that this is indeed a plus b expected value x. If I go on to variance, so now let's go to variance, and let's assume that I'm going to assume this time that it is a continuous random variable. So that way we can look at how they work with a continuous function as well. So here's my formula for a continuous random variable. And this time I'm going to use this version of the formula. And so the variance of a plus bx is equal to the integral from infinity to negative infinity of a plus bx, because this is my value, minus mu, which is the expectation of a plus bx squared times f of x dx. Well, let's work on this part in here. I've just learned, well, a plus bx. Well, this works out to A minus B expected value of x squared f of x. Well, I can see that the a's cancel. And what I can do next is I can factor out this b. I can pull it out as a factor. And when I pull out the b as a factor, it has to become squared. And then I have x minus the expectation squared of f of x. Well, this is simply the variance of x. So it's b squared times the variance of x. And so I can see that this a value goes away, and it's simply b squared variance of x. Now, these are proofs that you should be able to do something similar to these kinds of proofs and these ideas.